All right, today is April 30th, and now we are moving on to volume. So we're going to start with the same. So we're starting with our prisms and our cylinders. So for rectangular prisms, you just do length times width times height. And then for any other type of prism, you do the area of the base times the height. And then for cylinders, you do pi r squared times the height. Okay, so I went ahead and just wrote all the formulas that we're going to use so y'all can see them a little bit better. So the first one is a rectangular prism. So we just do length times width times height. So I'm going to do length times width times height. So it's just 9 times 17 times 24. Put it in your calculator, and I get 3,672. Now our units for volume are cubed. So for area, there was only 2 measurements. It was just like length times width, so that was squared. For volume, there's 3, length times width times height, so that's why it's cubed. Okay, number 2. So again, it's another rectangular prism, so that's length times width times height. So that's just 8 times 12 times 39. Plug it in, and you get 3,744 feet cubed. All right. Okay, number 3. Okay, so this is not a rectangular prism. It is a triangular prism. And I can see that because there's one triangle and then there's the other. So those are my bases. Okay. So the first thing I want to do is find the area of the base, which is a triangle. So that's 1/2 base times height. Okay. So the base of it is 11. Okay, so sorry, 1/2 times 11. And then the height of it is 5.4. And then plug that in, and I get 29.7. Okay, now the height they're talking about is the height between the bases. So what connects the 2 triangles? So it's this line, and this line, and those are all 16 inches. Okay, and then I just plug that in, and I get 475.2 millimeters cubed. Okay. All right, so on number 4, this is a trapezoidal prism. So if I'm looking at it, okay, again, I want to find the area of the base first. So that's 1/2 times height times base 1 plus base 2. I'm going to go ahead and highlight just one of the bases. Okay. So I do know my 2 bases are 25 and 39.4. Okay, I am missing the height, however, and how I'm going to find that is I need to use Pythagorean theorem. So if I draw in the height right here, I'm going to call that x. I can now use Pythagorean theorem to solve for x. Okay, so that's going to be x squared plus this little guy right here. I'm going to do 39.4 minus 25, and that's 14.4. So that's plus 14.4 squared is equal to this side, which is 30.6 squared. Okay. If I use Pythagorean theorem to solve that, I just simplify it, and I get 27. So now the height down here is 27. Okay, so then I can plug that in, and I get 869.4. So that's my area of the base. And then the height between the two bases is going to be 35. All right, so plug that in and you get 30,429 centimeters cubed. Okay, number 5, so this is where we move on to cylinders. So that's just pi r squared times h. Our r is 18, so that's just pi times 18 squared times 15. So that's 4,860 pi, which comes out to be 15,268.14 inches cubed. Okay, number 6 pretty much works the same way, except they give me the diameter this time, so my radius I know is half of that, which is 5.5. So pi 5.5 squared times 21. Plug that in, and I get 1,995.7 meters cubed. All right. Okay, let's look at our 2 application problems. So a cylinder with a 2 centimeter diameter is drilled through a triangular prism. Find the volume of the prism. So this cylinder basically means that it is hollow. There's just air in there. So what I'm going to do is I'm going to find the area of the triangular prism and then find the area of the cylinder and then subtract. So I'm going to do triangular prism first. So we're finding the volume, so I need to find the area of the base. So 1/2 base times height. Okay, so that's 1/2 times 7.1, or sorry, times 5 times 5, because there's the right angle. And that's 12.5. Okay, so then I want to use my volume, so I have 12.5 times the height between the two bases, which is 14. So volume is 175. Okay, the second volume that I want to find is the cylinder. And that volume is pi r squared times height. Our radius, they tell us, is, or sorry, our diameter is 2, so that means our radius is 1. So that's just pi 1 squared times the height of the cylinder, which is 14. So that's about 43.98. Okay, and then what I want to do is I want to subtract those two. And I get 131.02 centimeters cubed. Okay, and then the very last one, so we have a diagram of Eric's pool is shown. He plans to fill his pool to a depth of 4 feet. Okay. And with a hose that has an 80 cubic foot per hour flow rate, how many hours will it take to fill the pool? Okay, so first thing we want to do is find the volume. So volume is equal to pi, and he only wants to fill it 4 feet. Because you know in pools there's like a little bit of like extra. It doesn't go all the way to the top unless it rains. Okay, so pi r, our radius is half of that, half of 27, which is 13.5 squared, and we want 4 foot depth. Okay, plug that in and you get about 2,290.22 feet cubed. Okay, now we want to know how many hours will it take to fill the pool up. Okay, if the hose does 80 cubic feet per hour, so I'm going to divide by 80 cubic foot per hour, and that will give us 28.63 hours to fill the pool up. Okay,